Section 1.2 Mathematical Patterns. Our objectives are to define key terms of a sequence, sequence notation, recursive functions, and explicit, create a graph of a sequence, and apply sequences to real-world situations. Now, this section is a little strange because it's kind of like an overview of everything we're going to do in the next two sections. So we're going to kind of, in general, look at everything, and then in the next two sections, we'll look at an arithmetic and a geometric sequence more specifically. So for right now, let's talk about arithmetic sequences and geometrics. So those are the two different types that we're going to look at. And there are also two different types of formulas for these sequences. We have what's called a recursive form and an explicit form. So recursive form defines the terms in a sequence by relating each term to the ones before it. To get to the nth term in a sequence requires the computation of all the previous terms to find the value of a sub n, and we'll talk about that notation in just a minute. And the explicit form is a formula that allows direct computation of any term for a sequence without having to know the previous terms. So these are the two forms that we're going to have to know to write each of our sequences out. Now, let's talk about what a sequence is. A sequence is a list of ordered numbers. Each number in the list is called a term of the sequence. An infinite sequence is a sequence with an infinite number of terms. 3 dots or points of ellipses at the end of a sequence indicate the pattern continues for an infinite number of terms. So we usually use these braces to help us define a sequence. So let's say I had 2 and maybe 3, 4, 5, ... These 3 dots right here tells me that my sequence is going to continue on forever. Now for this, we have specific terms for our sequence. Since 2 was the first term that I wrote, this would actually be the first term, this would be the second term, third term, and fourth term, and so on. So for sequence notation, we use a variable and a subscript, and they're always positive integer subscripts. We don't use negative subscripts. So for this one, our first term we would write as u sub 1. The second term we would write as u sub 2. The third term would be u sub 3. N minus 1 means the term before n, and we actually call it the previous term. So u to the sub n minus 1 would be the previous term. And we use this when we're talking about recursive form. The nth term would be u sub n, and the n plus 1 term, which means the next term, would be the u sub n plus 1. Now, for the last one, we could rewrite this out as u sub 1 is equal to 2, u sub 2 is equal to 3, u sub 3 is equal to 4, u sub 5 is equal to 5. So that would be a way that we could write it. And then we could also come up with different formulas for these, which we'll talk about in a second. So finding the terms of a sequence. So if I want to find the terms of the sequence, this right here, this form is actually what we call explicit form, which we just talked about. And the nice thing about explicit form is that if I want to find the nth term, I can just go ahead and plug in those numbers in order to figure out the terms of the sequence. So for the first term, a sub 1 would mean I'm finding my first term. And notice that this n is also right here in my formula, so I'm really doing 3 times 1 minus 2 for my formula to get the first term, which would be equal to a value of 1. So the next one would be a sub 2 is equal to 3 times my n, which is now 2, minus 2, which gives me a value of 4. A sub 3 would be equal to 3 times 3 minus 2, which is equal to a value of 7. And a sub 4 would be equal to 3 times 4 minus 2, which is equal to a value of 10. So I can write out the terms by saying a sub 1 is equal to 1, a sub 2 is equal to 4, a sub 3 is equal to 7, and a sub 4 is equal to 10. So that would be the first 4 terms of the sequence. If I wanted to write this in sequence notation, I would use my braces and I would write 1, 4, 7, 10, and then 3 dots because the sequence, of course, continues on. it doesn't just stop at the fourth term. We could find the fifth term, the sixth term. And the nice thing about the explicit form is that I can just plug in numbers to find the next term. So if I wanted to find the 10th term, I wouldn't have to know the terms before it like in a recursive formula. I can just do 3 times 10 and then minus 2. So this would be 30 minus 2, which would be 28. So the 10th term would be equal to 28, which is nice. If instead I was given a recursive formula, which we'll talk about later, you would actually have to find all the previous terms up to the 10th term in order to find it. So that's what makes an explicit formula kind of nice. So now let's look at the second one. It says find the first 4 terms of this sequence. And that last sequence that we just did is actually an arithmetic sequence. And the reason I know it's an arithmetic sequence is because I have what's called a common difference. Notice that from here to here, the difference is 3. From here to here, the difference again is 3. And from here to here, the difference is 3. So because of that, I could write a formula for this, but we're going to not do that right now. We'll do it later. So find the first 4 terms of the sequence given this formula. So I'm going to do the same thing. A sub 1 is equal to 3 plus negative 1 to the first power. So if I do that, I get 3, and negative 1 to the first power is negative 1, so 3 minus 1 is 2. So a sub 2 would be equal to 3 plus negative 1 to the second power. Anything that's negative and we're squaring it is going to become positive, so 3 plus 1 now would give me 4. A sub 3 would be equal to 3 plus negative 1 to the third power now. Anything to odd power is going to be negative, so 3 minus 1 would be 2. And a sub 4 would be equal to 3 plus negative 1 to the fourth power, which would be equal to 4. So a sub 1 is equal to 2, a sub 2 is equal to 4, a sub 3 is equal to 2, and a sub 4 is equal to a value of 4. So if I wanted to write this in sequence notation, 2 comma 4 comma 2 comma 4 dot dot dot. And again, this is an explicit form. And again, we'll talk about that in a little bit. So simply listing the first few terms is not sufficient to define a unique sequence. The nth term must be given for our sequence notation, which is what we had in those last 2 formulas. Now, let's go ahead off from that for a little bit and talk about the graph of a sequence. The graph of a sequence is a function because each input corresponds to exactly one output. Now, the domain is going to be the set of positive consecutive integers, and actually, we're not going to be using negative for our subscript, so it's going to be, in this case, again, positive integers. So be careful that you can't have a negative subscript. The range is the set of terms that are given in the sequence. So if we wanted to graph the first 5 terms of this sequence right here, well, let's write it out. U sub 1 is equal to 1, U sub 2 is equal to 3, U sub 3 is equal to 5, U sub 4 is equal to 7, and U sub 5 is equal to 9. So if I wanted to graph this, I could put it in my calculator, stat plot, and then hit zoom 9 in order to graph it, or really you're just graphing it discretely on your graph that you have. So U sub 1 means we have the point, our first term, comma, and then what the first term is, which is 1. So we have 1 comma 1, which would be right here. The next one we have is 2 comma 3. So term 2 is a value of 3. And then our third term is a value of 5, so 3, 5. And then we can keep going. This would be 4 comma 7. And then the last one would be 5 comma 9. And this pattern does continue on, but for this, notice that they are discrete points. I am not going to connect it with a line because I can't have values in between 1 and 2 or 2 and 3, etc., because each term, again, has to be a positive consecutive integer. So this is what my graph would look like, and of course I could continue on for this. Now, if I wanted to come up with a recursive equation for this, we would have to figure out what the difference between each of the terms in my equation are. So if I look here, I notice that to in between each of my terms, from the first term to the second term, notice you have a common difference of how did I get 3? I added a value of 2 to my first term. So, and then from 3 to 5, again, I added 2. And then to get from here to here, I added again 2. And to get from here to here, I added 2. So we're going to talk about the recursive formula. Recursive formula consists of two parts. In order to have it, you need to know what your first term is, which in this case is a value of 1. And I need to know the previous term to get to the next term. So u sub 2 was equal to my first term plus, and we added a value, my common difference of 2. So when I did this, my first term is 1 plus 2, 2, which gives me 3. So then to get to the third term, I need to know my previous term, and my previous term is u sub 2. And again, I'm adding my common difference, which is 2. So in this case, I have my previous term, which is 3, plus 2, which gives me 5. U sub 4 would be equal to u sub 3, my previous term, plus 2. So 5 plus 2 gives me 7, and I could keep going. My fifth term would be equal to my fourth term plus 2, which is equal to 5 plus 2, which gives me 9. And if I wanted to keep on going, I could, but instead, to get to my nth term, what did I do? All these, notice, are u to the n minus 1, the previous term, because if you take this number here, 5, and plug it in here, 5 minus 1 would be 4. That's what gives me my previous term, plus my common difference, 2. So this would be my recursive form. So my first term would be u sub 1, and then I need the formula to find the nth term. So the formula is u sub n equals u sub n minus 1, my previous term, plus my common difference, 2. Now, for this, notice that if I'm starting off with this right here being 1, that means these n values that I have to be greater than or equal to a value of 2. Because if I use something less than that in my formula, just to show you, if I try to do u sub 1 into my formula, I would get u to the 1 minus 1 term plus 2, which is really u sub 1 would be equal to u sub 0 plus 2. But we didn't start off with a first term of u sub 0. Our first term starts off with u sub 1. So because of that, I can't have something less than or equal to 2. So it just to show you, if instead it's 2, I would have u sub 2 is equal to u sub n minus 1 plus 2. So u sub 2 would be equal to u sub 2 minus 1 plus 2. 2 minus 1 is 1, so my second term is equal to my first term plus 2. That's what we're doing every time we're plugging it into our formula. So again, if the value of n is anything lower than 2, then the formula would not work for my recursive form. So you have to also, again, state the values that are greater than or equal to n. So that would be the recursive form. And in order to use this form, I would have to know all the previous terms in order to get to the next term. So we also have the explicit form, which instead of having to know all the previous terms, I can just plug in my number that I want for a value of n into the equation and solve it, which we'll talk about in a little bit more depth in just a little bit. So a recursive formula defines the terms in a sequence by relating each term to the ones before it. The formula consists of two parts: an initial condition that tells us where the sequence starts, and 2, a recursive formula that tells us how any term in the sequence is related to the term that precedes it. So you're always going to have two different parts to your equation when you're writing this out. If you don't, you would get it wrong because you need to define how your sequence is starting. So looking at the first problem that we have, I would go ahead and start writing out each of the terms. So my first term is equal to -7. And why don't I start off with 0 here? There are certain situations where you can start off with 0, but in this case, if I'm actually given the sequence, I'm starting, this is the first place that I have, so that's why I use u sub 1. And then my second term would be equal to -4. My third term is equal to -1. My fourth term is equal to 2, and my fifth term is equal to 5. So I'm going to try to come up with a recursive formula for this. So the first part of my recursive formula is u sub 1 is equal to -7. Then I have to come up with a formula for the nth term, which is what we're going to try to figure out. So if you can't tell by looking at it, you can try to see if you can use your equation to help you. So u sub 1 is equal to -7. So u sub 2 would be equal to, how did I go from the previous term to the next term? Well, if you look, it looks like I'm adding each time 3. So if I add 3, I can get to the next term. So u sub 2 is equal to my previous term, and then plus 3. So if I were to plug 2 in here, I would get u sub 2 is equal to u sub 2 minus 1 plus 3, which is equal to u sub 2, let's write it underneath. So u sub 2 is equal to u sub 1 plus 3, and we already said u sub 1 is -7, so u sub 2 would be equal to -7 plus 3, which is where I get -4. And I could keep on doing this. So then u sub 3 would be equal to u sub n minus 1 plus 3, so u sub 3 is equal to u sub 3 minus 1 plus 3. U sub 3 then would be equal to u sub 3 minus 1 is 2, so my second term plus 3. So u sub 3 is equal to, my second term we said was equal to -4. So -4 plus 3 is where I get my value of -1. And we could keep on going. So instead of writing this out like that, we would say to get to my nth term, I have to take my previous term, u sub n minus 1, and I'm adding my common difference of 3 each time. For this, because I'm starting off with my first term being a 1 here, all my n values have to be greater than or equal to 2, because I need to know the previous term to get to the next term, so I have to be given the first term, so we're going to really start off with the second term to get our sequence. So that would be my recursive formula. So then let's look at the next one. So for my next problem, if I try to figure out what the difference between each terms are, well, it doesn't look like I can add or subtract anything to get from the first term to the second term, because there's not going to be a common difference. So in this case, this is actually a geometric sequence, whereas the first one was an arithmetic sequence because I had a common difference. Now I have a common ratio. So for this one, if I try to figure out how do I go from this term to the next term, well, notice that if I multiply this by 2, 1/4 times 2 gives me a half. 1/2 times 2 gives me 1. 1 times 2 is 2, and 2 times 4 gives me 2. So my common ratio, which we use r for that, is equal to 2. So if I want to come up with my recursive formula, I have to state my first term. So u sub 1 is equal to 1/4. And to get to my nth term, I would have to know my previous term, and notice I'm multiplying each previous term by 2. So 2 times u n minus 1. And because we're starting off with the first term, n has to be greater than or equal to a value of 2. So this would be my recursive formula. And again, alternate sequence notation. Sometimes it's more convenient to begin numbering the terms of a sequence with a number other than 1, such as 0 or 4, etc. For example, let's say that we have a ball is dropped from a height of 9 feet. It hits the ground and bounces to a height of 6 feet. It continues to bounce, and on each rebound, it rises to 2/3 the height of the previous bounce. We want to write a recursive formula for the sequence that represents the height of the ball in each bounce. Find the height of the ball on the fourth bounce. So the first thing I like to do is think about a picture. So I have this ball dropping from 9 feet, and then it's going to bounce up and then come back down, and it's going to keep on going until eventually it's going to stop. And on each bounce, so this starts at 9 feet, so we're following 9 feet. Each bounce we're going to 2/3 of height. So if we start with 9 feet, 2/3 of that we'd have to multiply, so 2/3 times 9 would give me a value of 6. So that means I'm going up 6 and then down 6 for my first bounce that I have. So then for the next one, we're doing 2/3 the previous height. So 2/3 of 6 would be equal to a value of 4. So now for the second bounce, I went up 4 and then I had to come back down 4. And then of course I'm going to keep on continuing. So 4 times 2/3 would be 8/3, etc. So to write a recursive form for this, now instead of starting off with a first term, I'm going to start off with u sub 0 because that means I have no bounces. So for no bounces, I start off a height of 9 feet. And then I need to come up with a formula for finding the nth term of my sequence. So for this formula, each time, notice I'm going by a height of 2/3. So u sub 1 was equal to 9, or u sub 0, sorry, is equal to 9. U sub 1 is equal to 2/3 times 9, which was equal to 6. U sub 2 would be equal to 2/3 times my previous term, which is 6, which is equal to a value of 4. U sub 3 is equal to 2/3 times 4, which is where you get 8/3. So U sub n would be equal to 2/3 times my previous term. So 2/3 times u to the n minus 1. And because now we're starting off with u sub 0, n has to be greater than or equal to a value instead of 1 or 2, it would be 1. So we can find our first term. So this would be my recursive form. Now, if we want to find the height of a ball on the fourth bounce, well, this is easy to do because all we would need to do then is just do 8/3 times another 2/3. So u sub 4 is equal to 2/3 times u to the 4 minus 1. So this would be u to the 4th is equal to 2/3 u to the 4 minus 1 would be u to the 3rd. So that's my third term. So u sub 4 is equal to 2/3 times my third term, which we said is 8/3. And so in this case, we get 16/9. Now, for this value that we have, instead of having to write it out, sometimes we can also use our calculator. Like let's say instead of finding the fourth bounce, I wanted to find the 20th bounce. Well, I would have to keep on multiplying 2/3 times the previous one in order to get what the 20th bounce would be, which might take you a while. So sometimes it's easier to put it into your calculator because we're not going to do explicit equations yet. So if I put this into my calculator, if you go to your mode on your calculator, notice if I scroll down, we're on function mode right now. This one right here stands for parametric, polar, and then sequence. So I'm going to hit enter there. Notice as soon as I do that, if I go to my y equals, it changes what this looks like. It's no longer y equals. Now we have our sequence notation. So I'm going to clear some of this stuff out. Now, n minimum. The n minimum means that I want to know what I'm starting off with for my n value. We did u sub 0 for my first term, so I'm plugging 0 in there. Now, u sub n is what this is right here, means we want the formula. So the formula we said was 2/3 and then to get the u in my formula, I'm going to hit second 7 gives me u. And then parentheses stands for the sub that we're going to do. To get the n, use the button next to alpha. So n minus 1 means my previous term when I write it like that. And then notice u sub n minimum means when we have our n minimum, which is 0. So u sub 0 is our first term, which you have to write in there, and our first term is 9. So don't worry about the braces. Sorry, to get the braces, it'll automatically do that for you. So if you hit down, notice it puts it there. So for this, if I were then to hit zoom 0, notice that it gives me a discrete graph for each of the bounces that I have. If I go to second value, and let's do 4, notice that for 4 I get 1.7777, etc. which is what we found when we did 16 over 9. So this is nice because if, let's say, I wanted to find the 20th bounce, instead of having to do all that by hand, I could just then scroll down in my table all the way down to 20. So on the 20th bounce, we're going to be at a height of 0.0027. So that's kind of cool that we can do that in our calculator. So then, again, the fourth bounce, u sub 4 was equal to 16 ninths. All right, so let's go ahead and do another example. And again, I'm just going to make a little note here to get this u hit second and then the number 7. Okay, so if the starting salary for a job is $20,000 and a raise of $2,000 is earned at the end of each year, work year, what will the salary be at the end of the 6th year? Find a recursive function to represent this problem and use a table and a graph to find a solution. So if it helps you to write it all out first, that would be probably a good idea. Now, for this equation, normally when you're starting off with salary, like my salary as a teacher, I started off with year 0. They don't really start you off with year 1. So instead of starting off with u sub 1, I'm going to do u sub 0 to stand for my first year. So my first year, I'm making $20,000 a year. And at the end of each year, you're going to earn a raise of $2,000. So then my second term, so u sub 1 would be equal to 20,000 plus 2,000, which is equal to, of course, 22,000. So that's how much I'd be making at the end of the year. So then u sub 2 would be equal to my previous term, so 22,000 plus another 2,000, so 24,000. So I could keep on going. U sub 3 would be equal to 24,000 plus 2,000, which gives me 28,000, and so on and so forth. So my recursive form would be u sub 0 is equal to 20,000, and to get to the end term, u sub n is equal to, notice these are all my previous terms right here, so u to the n minus 1 plus 2,000, and n has to be greater than or equal to 1 because we're starting off with a 0 term here. So that would be my formula. So if I wanted to figure out at the end of the 6th year how much we're making, well, I have to keep on going. I can't just plug 6 into my formula, because if I just plug 6 into the formula, I would have u sub 6 is equal to u sub 6 minus 1 plus 2,000, and then u sub 6 would be equal to u sub 5 plus 2,000. So this is what I was talking about before. For recursive formulas, it's hard because you have to know the previous term. Well, I don't know what u sub 5 is until I find it, so I can't just plug 6 into the equation like an explicit formula. So for this one, that means then I would have to find u sub 4. So u sub 4 is equal to 28,000 plus another 2,000, which gives us 30,000. And then u sub 5 would be equal to 30,000 plus another 2,000, so 32,000. And I guess I shouldn't have used 6 there because if we're starting off with year 0, so this would be your first year, this is your second year, third year, fourth year, fifth year, and then the end of the 6th year, you'd be making 32,000. So at the end of the 6th year, you are making $32,000. If I wanted to put this on my calculator, I could. So I could do the same thing in my calculator I did before. So my first term instead, on my calculator here, I would start off with 0, then I would plug the formula in right here into my calculator, and then this right here would be 20,000, and then I could scroll down and see that I would get the same thing. So let's look at another example. So for this next example, it says, a chord is a line segment joining two parts of a circle. The following diagram illustrates the maximum number of regions that can be formed by 1, 2, 3, and 4 chords, where the regions are not required to have equal areas. Find a recursive formula to represent the maximum number of regions formed with n chords. So our subscripts are going to be the number of chords that we have. So n would be equal to 1, 2 chords, 3 chords, 4 chords. And then use a table to find the maximum number of regions formed with 20 chords. So the number of regions formed would be down here. So here I have 2 regions. When I have 2 chords, I have 1, 2, 3, 4 regions. If I have 3, 1, 2, 3, 4, 5, 6, 7. If I have 4, I think this ends up being 11. So U sub 1, because that's our n value, so when I have 1 chord, I have 2 regions. U sub 2 is equal to 4, U sub 3 is equal to 7, U sub 4 is equal to 11. And of course, I could keep on going, so I need to find the formula for the nth term. Well, if you look here, is there a formula that we can come up with to figure this out? So let's go back up to U sub 1. So U sub 1 would be equal to 2. So we're going to start off with that for a recursive formula. And so then U sub 2 is equal to my previous term. And then how do we go from here to here? It looks like I added 2. So if I do that, I would get U sub 1, because 2 minus 1 is 1, plus 2, which is equal to a value of 2, because that's my first term, plus 2, which gives us 4. If I do U sub 3, that would be equal to my previous term, which is 4, plus, now if we look from here to here, I have a common difference of now instead of 2, I added 3 regions. So U sub n minus 1 means I have U sub 3 minus 1, which is 2, plus 3, which would be equal to 4 plus 3, which gives me 7. If I do U sub 4, I have my previous term, plus now the difference between these two terms is 4, so that's equal to U, and 4 minus 1 gives me 3, so my third term plus 4, which is equal to 7 plus 4, which gives me 11. So that means that for my formula, for my nth term, it's going to be equal to U sub n equals, notice we have our previous terms here, so U to the n minus 1, and notice that I have 2, 3, and 4, which is the same as my n value right here. So plus n. My first term we said was U sub 1 equals 2, and U sub n is equal to the previous term plus n. Since we're starting off with an n value of 1 first, that means that n has to be greater than or equal to 2 because I already am given my first term. So this would be my recursive form. So if I want to find out how many regions, the maximum number that I can have with 20 chords, well, that means that I have to plug in and find the 5th, 6th, 7th, 8th, 9th, 10th, all the way up until I get to the 20th term. So the easiest thing to do now would be to plug this into my calculator instead of having to do that by hand. So in my calculator, I'm going to go to my y equals. So my minimum in this case is not 0 now, it's 1 because that's the lowest chord that we have was a chord, 1 chord. And then now we have our previous term. So let me clear that out. So we have U, so second 7, and then parentheses, n minus 1 plus n. So I would write that in there. And our first term, in this case, we started off with was 1 chord gave us 2 regions. So if I go to my table now, just to look, you can go back up and check. So when I have U sub 1, and notice that if I go below 1, it's going to say error because we don't have 0 chords. Oops, going too far there. So if I go here, notice that one chord, you have two regions, two chords, four regions, three chords, seven regions, four, and so on. So all I need to go down is scroll down to 20. And notice that 20 chords, and sorry, let's keep going, but I have 211 for my solution. So U sub 20 would be equal to 211 regions. And again, I can't just plug 20 into my equation, because if you try to do that, U sub 20 would be equal to U sub 20 minus 1 plus 20. So U sub 20 is equal to U sub 19 plus 20, and I don't know the 19th term until I find it, and that would happen to each different one that you have. So that's why it's easier to just plug this one into your calculator. So let's go ahead and finish up the last question in class, and then talk about that later. So you don't need to do this, but I'm going to go ahead and keep doing the last problem so that if anyone's absent, they can do this. So for this next one, it says, Dr. Miller starts with 3.4 gallons of chlorine in his pool. Each day he adds 0.25 gallons of chlorine and 15% evaporates. How much chlorine will be in his pool at the end of the sixth day? So for this problem, we're going to start off with U sub 0. So U sub 0 would be equal to 3.4 gallons. So when no days have passed, I have 3.4 gallons of chlorine in the pool. And then I want to figure out a formula for the next one. So we want to figure out how much chlorine is going to be in the pool at the end of the sixth day. So if 15% evaporates, then you need to figure out how much is going to be remaining. So if 15% evaporates, then 1 minus 0.15 would give me, in this case, 0.85. So that means that 85% remains. And I'm going to use that in my formula because, again, I want to figure out how much is staying. So U sub 1 would be equal to, in this case, 0.85 times 3.4, and we're also adding each day 0.25 gallons, so plus 0.25 would give me my first term. So for this one, and I would keep on going for that. So U sub 2 would be equal to 0.85 times U sub 1 plus 0.25, and U sub 3 would be equal to 0.85 times U sub 2 plus 0.25. So if I keep on going, I can get my formula. So U sub 0, my first term, is 3.4. And to get to the nth term, I'm going to take 0.85, because that's how much is remaining, times U to the n minus 1, plus how much I'm adding each day, 0.25, for all n values greater than or equal to 1, since my first term is 0. So if I want to figure out the sixth day, I would have to go ahead and plug in into my calculator and figure out what it is. So I'm going to go ahead and stop here.